Mastering SQL is easier than you think, and I'm here to show you how Python data scientists do it in record time. SQL is the unsung hero of data science. It's what allows us to extract insights from massive datasets, build predictive models, and ultimately make informed decisions. But I know what you're thinking. SQL is boring, it's tedious, it's for database administrators. But trust me, that's not the case. SQL is an essential skill for any data scientist, and once you master it, you'll be able to manipulate and retrieve data like a pro. Think about it. Data is at the heart of everything we do as data scientists. We need to be able to extract, transform, and load data to build models, create visualizations, and tell stories. And SQL is the language that allows us to do just that. It's what gives us the power to ask complex questions of our data and get meaningful answers. But don't worry if you're new to SQL. I'm here to guide you through the process of mastering it. And by the end of this video, you'll be writing SQL queries like a pro. So let's get started. So what do you need to get started with SQL? Well, first, you'll need a SQL database. You can use something like SQLite or PostgreSQL, both of which are free and easy to use. Next, you'll need a code editor like Visual Studio Code or PyCharm. And finally, you'll need some basic knowledge of Python and data structures. Don't worry if you're not an expert in these areas. I'll explain everything in detail as we go along. If you're completely new to SQL, you might be wondering what the big deal is. After all, it's just a language, right? Well, the thing is, SQL is a powerful tool that allows us to extract insights from massive datasets. And with the right skills, you can use SQL to build predictive models, create visualizations, and tell stories with your data. Okay, so let's dive into the nitty-gritty of SQL. First up, we have select statements. These are the most basic type of SQL query, and they allow us to extract data from a database. Let's say we have a table called customers that contains information like names, addresses, and phone numbers. We can use a select statement to extract just the names and addresses from this table. Select statements are made up of several parts, including the select clause, the from clause, and the where clause. The select clause specifies the columns we want to extract, the from clause specifies the table we want to extract data from, and the where clause specifies the conditions we want to apply to our data. For example, let's say we want to extract all customers who live in California. We can use the following select statement. Select name, address from customers where state equals California. This will give us a list of all customers who live in California, along with their addresses. Next up, we have joins. These allow us to combine data from multiple tables into a single result set. Let's say we have two tables, orders and customers. The orders table contains information about each order, including the customer ID, order date, and total cost. The customers table contains information about each customer, including their name, address, and phone number. We can use a join to combine data from these two tables into a single result set. For example, let's say we want to extract a list of all orders, along with the customer name and address. We can use the following: join, select orders, but order ID, customers.name, customers.address from orders, inner join customers on orders, customer ID equals customers, customer ID. This will give us a list of all orders, along with the customer name and address. Now let's talk about filtering data. This is where we apply conditions to our data to extract only the information we need. For example, let's say we want to extract all customers who live in California and have an order total greater than $100. We can use the following SQL query: select name, address from customers where state equals California, and order total 100. Another important concept in SQL is sorting and grouping data. This allows us to organize our data in a way that makes it easier to analyze. For example, let's say we want to extract a list of all customers, sorted by last name. We can use the following SQL query: select name, address from customer's order by last name. We can also use group by to group our data by one or more columns. For example, let's say we want to extract a list of all customers grouped by state. We can use the following SQL query: select state count from customers group by state. This will give us a list of all states, along with the number of customers in each state. Okay, so now that we've covered the basics of SQL, let's put it all together in a live coding session. Here, I'll show you how to write SQL queries to extract insights from a real-world dataset. All right, let's take a look at this dataset. It contains information about customers, including their names, addresses, and order history. Let's say we want to extract a list of all customers who have placed an order in the last 30 days. We can use the following SQL query: select name, address from customers where order date, date sub cur date, interval 30 day. As you can see, This query gives us a list of all customers who have placed an order in the last 30 days. Now, let's say we want to extract a list of all customers who have placed an order in the last 30 days, along with their order total. We can use the following SQL query. Select customers.name, customers.address, orders.order total from customers. Inner join orders on customers. Customer ID, orders. Customer id where orders.order date. Date sub cur date. Interval 30 day. Okay, so now that we've covered the basics of SQL, let's talk about some practical tips for writing efficient SQL queries. One of the most important things to keep in mind is indexing. This allows us to speed up our queries by creating indexes on frequently used columns. Another important tip is to avoid using select. This can slow down our queries and make them more difficult to read. Instead, we should only select the columns we need. Finally, it's important to follow best practices for data normalization. This includes things like using unique identifiers for each row, avoiding duplicate data, and using consistent data formats. Okay, so now that we've covered the basics of SQL, let's talk about some common errors you might encounter. One of the most common errors is syntax errors. These occur when we type something incorrectly, like a missing comma or parentheses. Another common error is connection issues. These occur when we can't connect to the database, usually because of a problem with our credentials or network connection. Finally, let's talk about some common errors with SQL queries themselves. These can include things like incorrect column names, invalid data types, and forgotten keywords. Okay, so that's it for today's video on SQL for Python data scientists. Let's recap the main concepts we covered. We started with an introduction to SQL and its importance in data science. Then we covered the basics of SQL, including select statements, joins, and filtering data. After that, we did a live coding session where we applied these concepts to a real-world data set. Finally, we shared some practical tips for writing efficient SQL queries and discussed some common errors you might encounter. So what's next? I want to encourage you to practice SQL with your own data sets. Try applying the concepts we covered today to your own projects and see how you can use SQL to extract insights from your data. Also, leave a comment below with your experiences and any questions you might have. Thanks for watching, and I'll see you in the next video where we'll cover advanced SQL techniques.